So welcome to this session on JavaScript Windows Store apps for Windows Embedded. This is one of those sessions where we're going to wear two hats. We're going to have a quick look at the apps aspect of a digital sign. We're going to write a quick app, and then we're also going to deploy it to a Windows Embedded instance. Before we start, you might be wondering, why does this matter? Why should I care? So if we go to this next slide, that link down there, imagine that you're working for a company who develops and deploys ATMs, and you open up your mail one morning and you find that link in there, and you click on it, and you see this video of your company's ATM. This is the kind of part where your blood starts running cold. Of course, the advantage to this one is it does open up career opportunities in writing arcade machines. So, yeah. I edited this video down a little bit, but it starts off with a guy actually withdrawing some money from the ATM and then logging into some of the administrative features of it and getting a list of the last number of credit card numbers that came through it. It's some interesting details that you wouldn't want to compromise. Yeah. Awesome. I think this was over in Russia that they did this one. Yeah. So that's the kind of stuff that nobody wants to see happen with their product, right? Whether you're an IT pro, whether you're a developer, whether you're the project manager, or whether you're the CEO, you don't want this kind of situation to even come close to your organization. So, who am I? My name is Hannes. I've been working with Intergen now for the last 3 years. For the last year or so, I've been working with the Windows Embedded team, primarily with their marketing department. And we've been writing a lot of demoware for them to show off the particular uses of Windows Embedded across a variety of retail and health verticals, and some scenarios within that. Came to New Zealand a while ago, and I've been here long enough now to be mocked about my accent by Kiwis and South Africans. So expect some heckling from the front over here. Okay. Today's key message. When you're creating a single-purpose, multi-user application, you really should consider using Windows Embedded as a platform to host it. What we cover today? First block, some death by PowerPoint. Why use Windows Embedded? We'll talk a little bit about the different SKUs that's available, the different features that it brings to the table, and some deployment issues. Then when to use WinRT. That's the other side of this one. WinRT is a term that I use interchangeably for Windows Store apps. Windows Store apps is kind of a misnomer when you're talking about it in this context because they don't necessarily come from the Windows Store or through the Windows Store. So I use WinRT. Sometimes I'll talk about WinJS when I'm specifically speaking about JavaScript apps. Yeah. Then we'll have a demo. We'll develop a digital sign app. Very simple app. It's going to show as a Twitter feed and an image list and allow a user to take an image of himself and add it to the list. And then we'll deploy and lock down our app on an instance of Windows Embedded Industry. So that's the IT Pro hat over there. It's a 200-level session, so we won't go into any deep technical details. Really, today, I just want to show you what this Windows Embedded stuff is about and kind of pique your interest and start thinking about new ways that we can use it and combine that with Windows Store apps to create a new paradigm. This is absolutely the kind of stuff that you want to look at if you're going to be creating a new startup company. OEMs, the technology is easy to export, it's easy to sell, it's easy to move to places. OEMs that would be interested in this kind of stuff as well. So scenarios in which we'd use Windows Embedded, kiosks. Kiosks is an obvious one. These machines out that's strewn across the the TechEd conference where you scan your NFC device, that kind of thing. Great place to use these Windows embedded deployments because it allows you to lock them down. Can't get out of it, can't get to the sensitive information. ATMs, obviously another big thing. A lot of ATM companies write their own operating systems. They don't actually even use commercial operating systems. But Windows Embedded is going big in that world. Point of service used to be called point of sale. Point of service is kind of a new name for it because what they found is that people doing sales are now not only just doing sales. If you look at people walking about in a showroom type scenario, they might have a tablet. Currently, iPads are quite popular for that. But they might have a tablet which allows them to put through a sale, to do a card read so that the customer can pay with his credit card. They've got the details there for the products. So they're doing this sales advisory thing. They're doing point of sale, all of it kind of in a combined setting. Line busting in banks, for instance. Some things you just don't need to see a teller or a cashier. Somebody can come down the line with a tablet and help you out with whatever queries you might have if it's just something quick. Control panels. In factories, large facilities, they've got an incredible amount of connected hardware. One of our favorite demos and scenarios is based on a Fiat factory where they've got these screwdrivers with an Ethernet cable plugged into it. And the screwdriver measures the amount of revolutions that is applied to each screw and the torque with which the last revolution is applied. And that all gets fed back into central command systems with control panels showing where there's potential quality issues with these screws. Infotainment devices, another popular one. If you've ever seen the Ford Sync Fusion device, that's got Windows embedded underneath. Delta Airlines and one or two others are aggressively taking on Windows embedded for their in-flight entertainment systems. What was it? On Air New Zealand the other day, I think it was, that flight to San Francisco with the older 747. Every now and again, that the system needs to be rebooted, and you always see the software developers starting to smile as they get this further insight into how this system works. That one's based on Windows CE on that particular plane. Windows CE's older version of Windows Compact Edition, Windows Embedded 8 Compact, so it's come a bit of a way since then with rebranding and all that kind of stuff. So the last one, thin clients. Dell makes a thin client called the Wise line. HP makes some thin clients as well. Typically, they'll run Windows Embedded Standard, which is a componentized version. And these systems are surprisingly powerful for a thin client. We've been showing them at WPC where they've got Core i7s with 8 gigs of RAM and stuff, and you wonder to yourself, really? A thin client? Well, that's what's available these days. Processing power is cheap. So, next up, Windows Embedded is Windows 8. That comes with a caveat that I'll chat about in a minute. But for all intents and purposes, for now, Windows Embedded is Windows 8. It's got the same management, so System Center, Intune, Group Policy, Active Directory, all those familiar technologies that we use to manage our clients. We use those same technologies to manage the management. And there's the applications. Windows Embedded runs Win32 applications, .NET, C++, native, managed, unmanaged code, all those same applications, plus now the WinRT apps. The Windows Store apps is new with Windows Embedded, and you can run those same apps on Windows Embedded, and that's what we'll show a bit later on today. It's got the same deployment procedures. You boot off a USB, you install it, or you do unattended setups. You can use a product called, not a product, but an offering from Microsoft called the Windows System Image Manager. Now, when you start talking about these IT Pro type things, there's a lot of acronyms to get used to. So, forgive me if I have to look for the words now and again on those. So, yeah, deployment. You've got things like the System Image Manager that'll help you to set up unattended install scripts. Again, it's the same thing that you would use to do your unattended scripts for a normal Windows 8 installation. There's a few deployment tools that's specific to some SKUs of Windows, and we'll briefly talk about them as well. So what's the difference? Lockdown. That's the first and foremost thing. Windows Embedded is all about security. It's about having the confidence to take something like an ATM and put it out there in the world where you have no access or where you have no control over who's accessing your system, right? It's about giving a user interface to the big unknown masses out there. Those user interfaces need to be connected to your core infrastructure to be useful. Again, think about ATMs. They need to interact with the banks. That's a very risky interface to open up to the world. Digital signs is another great example of where you'll have something where there's nobody watching the people using this device. So you have to do some extra stuff to lock that device down. Some of the features that Windows provides you in this lockdown scenario is things like USB filters, where you can, at a very granular level, define which USB devices should be allowed to work on this device and block all others. It's quite different from just putting a carpet block on any USB devices. It allows you to do interesting things like plug a barcode scanner into a USB port and it still works, but plug it out and plug a flash drive in and it just ignores it. Very important when you've got to deal with peripherals. There's things like write filters. Write filters is a very big one. So with a write filter, you can set it up to basically make your hard drive read only. And then what it does is it'll create a layer on top of that, which is a temporary persisted layer. And your apps that require writing to the hard drive for things like caching and so on will still work seamlessly as if they've got full write access to the hard drive. But when you reboot your machine, that layer gets wiped and you get to start off from a clean slate. So if you think again about something like an ATM, what do you want to do when your ATM application breaks, when it crashes unexpectedly? You don't want to restart your computer in that same state, right? You want to send up a bug report, send your reports over to System Center, the stack trace, all that stuff, and you want to restart this ATM to a known working state. And that's what write filters will allow you to do. There's other things like the gesture filters. So because Windows Embedded is Windows 8, it also supports all the awesome touch things. Those touch things include the side gestures. So swiping in from the side, opening up the chime bar, swiping down from the bottom to close your app. Those are great for Windows 8. You probably don't want those in your digital sign. You don't want people closing your app. You don't want people being able to switch between things. You definitely don't want them to be able to go into settings by just tapping the cog. So you can lock down all of those side gestures. There's keyboard filters. If you've got a keyboard attached to your kiosk, you don't want people to be able to press things like Alt F4 or Control Delete, all those kind of keys. So you can really lock down all of those key combinations as well. Windows Embedded allows you to also specify scan codes, block particular scan codes. So if the kiosk is only supposed to allow you numeric entry, you can block any other key, which means that if an attacker plugs out your keypad and plugs in a normal keyboard, won't help. They still can't use those other keys that they've just added to your system. The next one is footprint. Footprint is an interesting one. There's two aspects to footprint. There's the physical image size on our hard drive, and then there's basically the running size, what's in memory. So about the image size, with the Windows Embedded 8 standard SKU is a modularized, componentized SKU, componentized version of Windows 8. It allows you to pick what components you want, and by components we don't mean features like what you get through the normal add or remove features, but actual components like the shell. You can create a Windows Embedded 8 image without the normal shell, without the touch components, without a network stack. That'll bring down your footprint significantly. If you need to go even smaller, there's a product for that. Windows Embedded 8 Compact is one that's kind of weird. You actually develop that one in Visual Studio. In Visual Studio, you load up some plugins and such, and it allows you to configure a whole operating system. Then, in terms of memory footprint, lots and lots of services that's on by default in Windows is not on in Windows Embedded, thereby reducing our memory footprint, our processing footprint. And yeah, you don't have to spend days and days tracking down how to disable everything. Then the last one is branding. Branding is, again, one of those that's different across the SKUs. Some give you more options than others. But you can do interesting things like the startup screen. The Windows startup screen can be replaced with your company's logo. So when your ATM is booting up, instead of seeing Windows, loading Windows Embedded, you'll see Bank of New Zealand or ASB or whatever be the case. There's other branding options as well, but we'll leave that for another day. So meet the SKUs. These are 5 of the SKUs. There's another one, Windows Embedded Server, that I haven't got on here. I don't know much about the server product, and so that's outside of the scope of this talk. What's interesting about these is these top 3 over here. These are the Windows Embedded. These are the Windows 8 variants that I was talking about earlier. So when I said that there's a caveat to today's talk, it means that only those are Windows 8. This guy over here, Windows Embedded Handheld, is based on Windows Phone, and its release schedule aligns with Windows Phone. It's got the same APIs as Windows Phone. So with Windows Phone moving to the Windows 8 kernel, the same applies for this guy. This is now also moving to the Windows 8 kernel, albeit with a handheld/phone differences. And then there's Compact. Compact uses a lot of the same components, but it's not the same. For instance, Compact doesn't run .NET 4.5. It doesn't run WinRT. It does have .NET 4.1, I think, which is the one that came with Silverlight. So interfaces on Compact will typically either be Silverlight or C++, or they'll be headless. Think about, again, the screwdriver. It doesn't have a display. It just needs to talk to a server. Another example of that is ticket machines, where you put your ticket in a parking lot. That's where Windows Embedded Compact will most likely be used. Now, with the Windows 8.1 updates, that's interesting as well. So it turns out that Standard will only be updated with major versions of Windows. So it's not getting the Blue update. A number of the features introduced by Blue will only be enabled in Standard with the next update, so Windows 9. Standard will be Rev to 9 along with that one. Industry and Pro, however, they do get the Windows 8.1 updates. They are in line with the regular Windows client releases. So when Windows revs, Windows Embedded Industry revs. The same goes for Handheld. That one is aligned with Windows Phone. When Windows Phone revs, Windows Handheld revs, and Compact has its own schedule. So next up is the benefits of WinRT on Embedded. Again, please forgive the fact that I have 10 different names for the same thing. WinRT, modern apps, Windows Store apps. Why should we care about using those on Windows Embedded? Windows Embedded has come along just fine, supporting only Win32 apps until now, but the world is changing. Win32 apps don't allow us to write JavaScript apps that take advantage of all the built-in system features. It's limited. So far, JavaScript has been limited to what the browsers have chosen to allow it to do. So you'll find that some of our competitors, like Google with their Android system, are opening up a lot more of those native interfaces to JavaScript apps, and similarly, Microsoft is doing that through the WinRT apps. So native JavaScript apps allows you to use your existing JavaScript skills to write an app that can interact with your barcode scanners, with Bluetooth devices. Have you guys seen the Sphero balls over here? You can write a JavaScript app that'll control your Sphero ball through Bluetooth. You can write apps that'll talk to a number of different interesting peripherals that utilizes the advanced ADF Active Directory interfaces that's been made available through Windows. Next up, we can share components with consumer offerings. So if you've got a digital sign in your store, let's take a video store, for instance. They've got an app that allows users to search for videos. And they've spent some time working on the interface of this app and the data connections to their backends and stuff. So how about they put up a digital sign inside their shop that allows a customer to come and browse their catalog on the sign, and the sign points out where in the store to find this thing. So they can deploy this app through the store. People can do it on their tablets as they come in, or they can use the digital sign. The digital sign can offer them extra features like the barcode scanner. Bring a movie over, scan the barcode, see some trailers on the sign that they wouldn't be able to do with a Windows Store app. But because you can share these components, writing that digital sign means you only have to add a little bit of code, just that extra little bit. And it doesn't have to be Windows Store certified. It doesn't have to be compliant code, because you've got the ability to componentize all these things. So you can take all your Windows Store certified stuff, put it in your app, deploy it, and the rest of it you just put into your Windows Store app running on your digital sign. Assigned access on Windows 8.1 is another interesting one. If you've got Windows 8.1 systems in reserve, some spare systems, you can take your Windows embedded app for your kiosk, load it onto Windows 8.1, set up assigned access, previously known as kiosk mode, and roll that computer out. So suddenly you've got more flexibility. You don't have to set up another instance of Windows Embedded. You can reuse this existing computer that you have. If you've got 20 operator stations, but only 10 work at a time, you can utilize those other 10 computers in assigned access mode to run your digital sign app. So again, make use of this unused computing power. And finally, there's the runtime sandbox, the WinRT sandbox. Again, security. It allows us to make use of third-party apps with more confidence that they won't break anything on the system, that they won't have access to our system at a level that causes them to wreak havoc. So built-in security through that one. So WinRT apps isn't the silver bullet. It isn't the only way forward. Microsoft will continue to support Win32 apps. They will continue to support managed and unmanaged code. There's reasons where you wouldn't want to use Windows Store app. Deployment requirements is one. On Windows Embedded, there's the same sideloading requirements as that you would find on normal Windows 8. You need sideloading licenses, or you need an enterprise version of the SKU joined to a domain to load it. You may need things like Windows Intune. There might be requirements that mean that it's just not feasible for your organization to load these apps. So yeah, in that case, you'd stick to Win32 apps. Peripheral dependencies. The WinRT stack does require you to use peripherals that has Windows Store compatible drivers. Either that, or you have to write a custom driver. Sometimes we've got legacy hardware where the manufacturer isn't going to write a driver for us, and we don't want to write a driver. So in that case, we will continue to use the interfaces for Win32 that we've always been using. Same goes for API dependencies. Some apps just need to reach deeper into the system than the runtime sandbox will ever allow a Windows Store app to reach into. So in that case, yeah, you'd continue sticking with your app that you've always used. Windows Embedded has a feature called the shell launcher, which allows you to take your Win32 app and set it up as the shell. So you don't have any Windows interface then at all. And it still maintains its management interfaces that it normally would. So you can still manage your computer through System Center. But that's not going away anytime soon. And the guys on the embedded team knows that there's a lot of Win32 apps out there that's going to stay out there for a long time. So you don't have to worry about it going away anytime soon. So every good presentation contains at least one demo, they say. Let's write a quick app over here. So Visual Studio. Let's start file, new project, old chestnut, blank app, and we'll call our app TechEd Sign. Okay, so starting up with this app, we'll see that there's a lot of stuff that's came in from the blank template. We don't necessarily need all of this, so we'll just go ahead and delete some of it. This the concept of launch parameters is something that you'll generally not worry about too much with these embedded apps. Typically, they'll only be launched from the start menu. And actually, they'll typically be launched automatically through a thing called App Launcher. So, yeah, people won't access them by clicking links. That said, you don't have to limit the user to just one app. You can have multiple apps. You can have multiple apps running on your digital sign. One can invoke the other. They can be invoked through NFC, through barcode scanners. But for today's demo, we'll just deal with launch events. So, no checkpoint. Our app is always going to be in the forefront. It's a digital sign. There's only going to be one app. People aren't going to switch between us. So it's not going to be hibernated. It's not going to need any of that. If it does close down, it'll just reopen up, and we want it to start from a known state. So, having done that cleanup, let's go have a quick look at the HTML. Okay, standard HTML, we'll delete that tag over there. Oops. And we'll pull in some HTML that I handily wrote beforehand. I hate it when people try to type in presentations and it's just, it never works. So, basic structure. We've got 3 divs. We've got a header, we've got a main container, we've got a footer. Welcome to TechEd. Let's run up this guy. Pretty ordinary. So, let's style that up a little bit. First off, we'll change our default CSS. Now, here's an important thing. Well, you can use the default Windows Store styling, but you have to ask yourself whether it's the right thing to do. Because your user on things like a digital sign or a kiosk or an ATM won't know that it's a Windows system, you can't rely on those same affordances, right? So things like the back button, the app bar, that kind of hidden functionality that we rely people on knowing because they've used it in other apps, because they know Windows, we can't rely on those same affordances in this scenario. So whilst that styling and stuff is there, you can use it, you don't have to, especially if you're not going to deploy your app through the Windows Store. So there won't be a certification for it. You can still run the certification packs locally to make sure that everything is kosher, and you should, but you don't have to worry too much about the styling. Do the styling in a way that makes sense for the application. Okay, in this case, we'll reuse that UI Lite one. Then we head over to our CSS. And we'll pull in some basic styling. We'll delete this stuff. Now, these media queries over here that deal with snap states from Windows 8.1, they are not really relevant anymore. But you do need to, in Windows 8.1 apps, take into account that your app won't necessarily be full screen. Again, with digital signs, don't have to worry about that. Your app's going to be the only one to run, so it's a bit easier. So if we have a quick look at the CSS over here, what we've done over here is on our body tag, we've set it to display as an MS grid with 3 rows, 1 column. Always specify this column width, because otherwise it only sizes to its contents, and it can be a hard one to track down. People often ask me about whether to use the grid or the flexbox. I prefer the flexbox use. It's more widely adopted. All the browsers now support flexbox. Well, all the new browsers support flexbox, but only IE supports the grid. But the grid has its uses. The downside of using a grid is that its children needs to be involved with where in the grid they're laid out in. With a flexbox, the children just don't care about that. The container cares. So in this case, we use the grid. Then we've got a header. Put it in row 1. We've got some padding set to it. We overwrite the font size for our H1. Again, we don't have to stick with the Windows Store guidelines when it comes to styling these things. We can use whatever makes sense for our application. Then we've got our footer. That one's a flexbox. I'm going to put a few items in there later on, and I want them to be side by side. I hate divs, floating divs. They're so hard to work with. They never do what you expect them to do. So the Flexbox has come around, and finally we can free ourselves from the floating divs and have layouts that make sense. In the XAML world, we've had stack panels for ages. A Flexbox is the same thing as a stack panel, basically. Then we've got our main container over here. In row 2, again, we use a Flexbox layout for that one because we're going to have multiple items in it, and we want them to be side by side. All right. So let's run this guy up now that we've done some styling. Looks a fair bit different over there, right? Now, next up, we'll embed a Twitter feed into our app. That's an interesting one because it sounds a lot harder than it is. Twitter has recently come out with a thing that they call widgets. And if you go to your Twitter homepage, click on the cog to go to your settings, and you'll see the widgets down here. You can go and create new widgets. There's no API keys or stuff like that involved in it. We go into edit now. And then you set a few options. They give you a preview of what it looks like, and they give you some code to copy and paste into your HTML page, and it just works. So that's awesome. Let's do that now. It's a bit ugly, but we'll sort that out later. So let's run this up and see the power of Twitter, or maybe not. Yeah, what we see over here, important. Whenever things aren't going the way that they should be, have a look in this guy over here. Sometimes it'll show some interesting stuff. In this case, it's showing us that it can't load that widgets file, this JavaScript file from the Twitter platform, because an app can't load remote web content into the local context. So this brings us into another discussion in terms of the runtime sandbox. You've got local context and you've got web context. Again, that's Windows making things more secure for you. Local context has access to all of the WinRT APIs. So generally, you wouldn't want unknown content to be pulled in and given complete access to your file system, for instance, or your peripherals, or that kind of stuff. Maybe your printers. So by default, Windows will throw a message if you try and pull in stuff from the web into local context. Fortunately, the guys have also acknowledged the fact that despite those security things, we actually do sometimes want to display web content in our app, right? That's half the reason why we like using this JavaScript stuff, because we can so easily integrate the web with our apps. So to do that, we have to be a little bit more sneaky and create an iframe to host our content. All right. Easy enough. We've got our iframe, and we just point it to an HTML file on our hard drive. In this case, we'll call it Twitter frame. And we'll add it. HTML page. Right. And then we embed this guy over here. Now let's have a quick chat about something interesting over here. The way that we've referenced it over here, generally when we go MS-AppX, and you'll see that when you load up images into your apps, it'll often prepend the URL that you gave it with this MS-AppX. That's merely telling it that the file that you want is located within your package. Okay? But if you reference it like this, it'll load the contents up, but we'll still get our error about the local and web context. So by adding this -web, we're telling the runtime to load it up in web context. So let's have another look. Hopefully this works now. It takes a while though. And there we go. There's our Twitter widget. It's kind of small and not really useful at that size. So let's just add a little bit of CSS again to style it. Down there. Now you can just set this width and height on your iframe directly as well, but I prefer to do it using CSS. And there we go. Now it's nice and big. Okay. Let's have another quick look at this HTML. Now, one of the things that we can do over here is not use this script tag over here. If you have a look at what that script tag does, it really just determines whether you're in an HTTP or an HTTPS context, and then creates a URL that points to their widgets file on their platform and downloads that script tag. What we can do is optimize that out by deleting the script tag. And then let me just stop the app here for a minute. And so we can download that file ourselves. I'm not going to do that. I've already downloaded it. Oops. And we're going to use jQuery later on as well. So let's just pull both of them into our app now. Right. Then from the Solution Explorer, we can just add this reference to widgets in our head. And we can run it up again. That should work. There we go. It's even a little bit faster now because it doesn't have to go and download that widgets file. Generally, with embedded apps, you're not too worried about the app startup times because it's going to happen once and your sign will probably run for the rest of the day. So it can do a little bit more in the beginning, but it's a good idea to do these optimizations just as a matter of completeness. The downside of doing this is that if Twitter changes their widget and changes the link over here and their interfaces, we'll still have the old widget, so our thing will probably break. You might want to just set up a test somewhere that makes sure that your widget is the same as that one and run it on your CI server. Okay, so enough of Twitter. Next up, we'll pull in a list of images. So what I've done is I've gone to the TechEd website and I've downloaded a bunch of images of several of the Microsoft speakers, and we'll just embed some of those into our app. So image list, pull it in. We've got a div over here, the image list container. That'll just be the place where we put all our images. I've got some seed image data. Oops. Let's go to our default.js, put it in over here. So that's just images that's going to be in our solution, some C data. Generally, you would get this from a server or somewhere, but we try not to rely too much on the internet in these demos. Reference jQuery. If we go back to our default.html, then we'll pull in our jQuery reference. When you're pulling in third-party libraries like this, it pays to just use the normal debug version that's not minified, that's not compressed, right? Because you're not paying a penalty for downloading it. It's already in your app. You're deploying your app with these libraries included. And it's so much easier to debug when you can actually see the proper code that you're running against. So, okay, we've got jQuery over here because JavaScript is just really hard to write without it. And then an app ready event. It's a good idea to have a look at the life cycle of JavaScript apps because you can initialize your app over here. If you do it over here, generally you would want to chain a process to that promise to that process all promise over there, and that's stuff that'll happen before your splash screen gets torn down. If you do things in the ready event, that's code that'll execute after your splash screen has been torn down. So there's time limits. If you're going to submit your app for Windows Store certification, you want to be within certain parameters. So some of it just won't be a good idea to put in there. In this case, we'll just put all of it in our ready event. And then let's add a little initialize function. This guy looks scarier than it is. All we're doing over here is we're getting a query to that container element that we created. And then we're building up some HTML. So this map function will go through our seed images array. And then for each item inside that array, we'll create a piece of HTML, which is a div that has an image in it. And again, we use this MS AppX way to reference our image because it's in our package. Okay. So let's just get it into our package. So drag it into headshots. There we go. Right, so we've got our headshots now. So we've got a piece of HTML for each one of those images. This join guy over here just takes all our items and all our strings and joins them together with empty space, so that we've got one long piece of HTML that we've stored over here in this variable, and then we set the inner HTML to the seed images HTML. That's a dangerous one over there. That's one that easily breaks, because WinRT has several ways that it validates the HTML that you're assigning. Again, it's to harden your application against outside attacks. So in this case, you'll see it works, but if we were to change that closing tag over there to not be like that, but to be like that, that still seems like valid HTML, right? We've got an image tag and we've got a closing image tag. Right. Suddenly we get an exception when we set the inner HTML, because that HTML doesn't pass the tests that the WinRT runtime performs on it. So it says that it might be malformed HTML, and therefore it's not going to allow that to come in. The same as when it contains script tags. You want to be real careful with script tags. There's a way to come around it. You can surround this function with msapp.execute unsafe local function. I can never remember that one unless I rehearse it 20 times before a presentation. So just search for it on the internet and you'll find it. You should try to avoid using that, right? If you find yourself in a situation where you're using that, maybe reconsider what you're doing in terms of the design. Maybe create your DOM nodes in a different way. Now, one of the reasons why I like doing this HTML over here is because it's a performance optimization. Technically, you're supposed to be creating your DOM nodes and then adding your DOM nodes to your other DOM node one at a time. That's the preferred way of doing it, but it's slow. It's really, really slow. Every time you access the DOM, it goes off into another process. It recalculates layout. It re-renders stuff. It can get really slow. So the guidance out there in terms of performance optimization is to batch all of your DOM accesses together, right? So you want to create one piece of HTML, add it to your DOM, one access, one recalculate of your flow, one re-render, and you're off running again. Okay, so obviously the way that these images are displaying at the moment isn't particularly nice. So let's add a little bit of CSS over there. And we'll use this guy. So all we're doing over here is we're setting the size of our image list container. We're saying it should have 80 pixels of margin on the left, and it should have 200 pixels width for an image. We're not setting the height. If you set the height and the width, it'll change the aspect ratio of your image. If you only set one or the other, then it'll maintain that aspect ratio. Then we've got this div over here. So every div in our image list container we display this inline block that'll just allow them to be next to each other. We set the width and the height and to 200 pixels, so we want squares. And then the overflow is set to hidden, so it'll just, basically it's a nice way of cropping images without them spilling over and looking weird. You can also do that if you use the background image tags, background image attributes. There's ways of doing that as well. And then background color black. So now if we go F5 again, we'll see they're all laid out quite nicely next to each other. Now, one of the principles of Windows Store apps is that they're fast and fluid. There's movement. It needs to be interesting. So let's start doing some work on that quickly, because that static list over there is not particularly interesting. We'll pull in some cycle images text. Now, you can use jQuery plugins like jQuery Cycle 2 to do this part. I thought, let's make it not that complicated and just write one line of code to do it. I ended up with 3 lines just because it's more readable. and some people will break this up into 10 lines. But anyway, what we're doing over here is we're just taking the last child in our list and we're putting it in the beginning. We're moving it from the end to the start. All right? So we run this up again. We're doing that every 3 seconds in our interval. When you work with intervals and timeouts, you need to be careful with those. When you navigate away, the elements go away, but the JavaScript is still executing. So you can get exceptions when the code that's still running tries to access those dominoes that don't exist anymore. Windows 8.1 brings in a disposable pattern and disposable infrastructure for JavaScript apps. That's useful for clearing out that kind of stuff. So we'll see over here, our images are just cycling through now. It's certainly fast, but it's not fluid. It's kind of not cool. So again, our CSS comes to the rescue, and we just style the cycling images. Okay, so we add a 1-second transition. That's a CSS3 transition. Those are really cool. There's a site called the IA10 test drive site, and they've got a sub-site or section on HTML5 and CSS3 tags and stuff. You want to go have a look at that at some point. It shows you how to use animations, transitions, transforms. It's a nice sandbox in which you can do these things. So you can change the values with a slider, and then there's a live preview of the effect that has. So in this case, we're saying any CSS change should transition over a period of 1 second. And then we just go and say every 7th and every 7th plus 1 image, and the last one should have a width of 0. Height of 200, but width of 0. Let's see what that does for us. Ah, cool, eh? The cloud roars in applause. So, very simple CSS. If you're going to be cycling images, you'll probably want to add a lot more code, a lot more CSS to make it more rugged. But in this case, it serves the purpose to show how much we can achieve with very little code. Now, next up, we'll take this thing to the next level, because everything we've done over here we can do in a web page. Right? There's nothing here that's using our device so far. So there's no point in writing this WinRT app and going through the associated pains of deploying it and so on, when you could just point your embedded device at a web page. So let's remedy that by adding in a button. Where's the button? There we go. All right. So we've got a button over here. This funny thing over here, that's a Unicode glyph. If we hover over it, we'll see that ReSharper or Visual Studio doesn't support Unicode anymore. Yeah, so we've got a button and we've got a label for it. And I have written some CSS for that as well. There's a theme here with the styling in the CSS that I hope people do notice. Don't do your styling inside your HTML. Style the Add Me button. Again, it's not quite as scary as it looks. This button style over here, I pretty much just stole from the app bar button style in the themes. Go have a look in there sometime. There's some interesting stuff in there. Then a label is a label, and we've got a hover and an active state for our button. Hover is an interesting one. Always be careful with hovers. You cannot have behavior that depends on hover, because fingers don't hover. Fingers only click or don't click. They don't hover. So you'll notice if you're browsing the internet on your tablet, there's a lot of sites that use it for their navigation. They want you to hover over the thing, and then a context menu opens up, and you click on that. And every now and again, they forget to actually implement the part where you click on the header, and nothing happens, and you can't get to the context, and you're just stuck. So yeah, be careful with that. Yeah, let's run this guy up now, see what that looks like. So we've got this guy down here, and nothing happens when you click it, because in this label we said that it's for that button. If you click on the label, the button will click as well. So again, that's just a nice thing to make it easy for your users to use this thing. If they mispress the, I don't have a touch screen, but yeah, If they mispress, then it'll still work. Traditionally, we'll put these things inside an app bar, but as I said earlier, your user isn't going to know that this is running on Windows 8, so you can't rely on that affordance. You can't rely that they'll have an app bar. I think Nigel just spotted himself in the list. And yeah, you can't rely on the app bar or those edge gestures. You know, on a sign, we would actually want to lock down those edge gestures, which means that an app bar won't even be invoked. So you want to put your buttons on the canvas. Right. Now, buttons are only useful if they actually do something. So basically, the last piece of script that we need over here is a click handler. Again, you'll see we're using the jQuery, right? JavaScript apps is awesome because it allows us to use all that existing IP out there that we've written for our websites, that other people have written for their websites. Sometimes even the stuff that we've blatantly stolen from other people's websites. So yeah, let's reuse that stuff. Let's reuse our skills. We've add a click handler. And then this stuff in here is just taking a photo. This pretty much comes just like that out of the MSDN samples. Always have a look at those MSDN samples if you want to know how something works. They're pretty cool. They show you all the different ways of using it. Don't get hung up about the architecture pattern that they use for those samples. That sucks. You don't want to look at the samples for architecture patterns. There's other things for that. The samples architecture reflects the fact that they are kind of written in a way in which they get generated out of snippets. So yeah, they're great for these kind of things. If you want to know how a specific feature works, go look at the samples. And you can download all of them in one go. It's about 300 megs, I think, for all the samples in all the languages in one sample pack. That's pretty cool. But make sure that your computer is not tethered to your mobile before you do that. So capture UI, capture file async, .done. Difference between done and then, that's one that I often get asked. Then will just bubble up exceptions. Done will throw an exception if an exception is thrown inside anywhere along the chain. Done is normally what you use right at the end of your promise chain. You won't return a promise from done. So all we're doing over here is we take a photo, we get the photo passed in, we create an image URL out of it. That URL.create object URL is an interesting one. I have tried to find something similar in XAML apps and then eventually had to give up on that idea and find out that there's a different way of doing that stuff in XAML apps. So what this will do is it'll create a blob for you, and give you a URL back to that blob. And there's a few different things that you can pass into it. You can pass an image into it, a stream, a video stream. A while ago, we used a JavaScript library for detecting faces on a digital sign. And that library worked by having a video element, and then you attached your webcam to the video element. So the video showed the video coming from your webcam, and then you created a stream out of the video element using this create object URL, passed that into that library, and then that could, via this stream, get images out of the video element to analyze. And it took us a little while to figure out because all the samples for it was written for HTML pages that don't work in IE, that uses some thing specific to Chrome to get the stuff out. But yeah, eventually we got it figured out. Container elements, all we're doing over here is just adding our image to the list. So let's run this up and out of, okay. Important thing, the app manifest. Whenever you write all this code and you F5 and yes, it's going to work, it's going to be awesome, and then it doesn't. And this is an interesting one because it just says to go to the settings and have a look that you've got permission. So you go to the settings and it breaks for some reason over there. Okay. Ah, yeah, that's because I know that bug and it's in there for a reason. I'll show it to you later. But anyway, so if you go to the settings for that app, you'll see there's no camera permission there to set. You can't give it permission. And the reason why there isn't is because we haven't declared it in the app manifest. So app manifest is uber important. You have to know what to set over here. So in this case, we'll just declare that we're using the webcam, and run that up again. And then add my photo. Now, can it use our webcam? We want to allow it. That's very white. Okay. And there we are, right there next to the goo. Thank you. So, yeah, that dialogue that came up about the permission, that's an important one to be aware of when you're doing these Windows Store apps for your embedded system, because the first time that this app runs, it's going to ask you about those permissions. So you want to make sure there's somebody there to click the button. I don't know about a way to automate that yet, but you need to keep that in mind if you're going to do this. Okay, cool. Now, last piece of code to come into our sign is an error handler. So there's a neat trick that you can do with these Windows embedded apps that you can't do with normal Windows Store apps, and that's to provide an exit code. So normally when your Windows Store app exits, it's because it crashed, and there's no way to really give anything back to the system. It just takes what it can from your app and it sends it up in an error report to the Windows Store, and yeah, you get to pour through those error reports. With embedded, we can specify a custom exit code. Right? So if you're thinking about a point of sale machine that has this app loaded, but you're using things like AD to tie auditing and stuff back to the operators, right? It requires your operator to log into the machine, work a shift, and at the end of it, log out. Now, you could have her restart the machine, but that seems inefficient when the next person is right next to her, and that person wants to log out. So you probably want to provide a logout button, because you don't want to allow her to do anything else. So you don't want her to be able to go to the start screen, for instance, all that kind of stuff. So you have to provide some way of getting out of your app and logging out. So you can do that by providing a button, and give your button a click handler that'll call msapp.exit, I think it is, exit or stop. Again, that's something that you can't do when you're going to send it up for Windows Store certification. They frown upon it. But with embedded apps, you can do that. And you can provide a custom exit code, right? You can have several buttons. You can have a restart computer button inside your app. All that button does is it outputs this exit code, and it stops the app. And Windows Embedded will know what to do with this exit code that you've provided because you're going to tell it what to do. And I'll show you how to do that. Okay. So in this case, on error, we're just going to output a 1. Normally, what you do with that will depend on what your app is being used for. If it's an ATM and your app crashed, you probably want to restart the machine. Make sure that the hard drive is wiped and that you're starting back from a known state. Okay. If it's a digital sign, you might just want to restart the app. Okay. So, we've got our slides back. So, quick slide over here. Deploying WinRT apps in real life, there's sideloading requirements. Same applies to Windows Embedded. In Windows Embedded, there's enterprise versions of these different SKUs. The enterprise versions will allow you to 11:40. Are we going over our time here? It seems like it. So the enterprise versions will allow you to sideload apps. Otherwise, you need to purchase a sideloading license. Provisioning is a way of deploying apps. I'll show that to you in a minute. Logon scripts is a script that you can run when a user logs on that'll run some commands to do stuff. And then Windows Intune comes with System Center. It's a way of deploying apps through a web portal. So Windows 8 Industry, what I've done over here is I've already installed the SKU onto a VM. To do that, you basically create a bootable USB drive, plug it into the computer, start up, and you get this kind of interface over here where you can set some, yes, of course. Yeah, so you can set up some parameters and stuff for how to install it. Let's back, set disk configuration, so what to do with the disks on it. It's kind of similar to normal installing Windows 8, apart from this guy over here. Boot to audit mode. You can enable that, and the first time that it boots into the operating system, it'll be in a special audit mode where all your lockdown features are disabled. So that allows you to then complete your setup of the system, and then on the next reboot, all your lockdown features will be enabled. Protect the OS as write filters. There's a quick way to just enable the default write filters. Protect special keys. Same thing. If you enable it, you can fix some keys. These are just real easy ways to get going. So let's not install Windows Embedded just now and pop to this one that has it pre-configured. So what I've done over here is I've got some commands that we'll be running. Because this is a developer demo, we'll use a developer license. It's not an enterprise SKU and it's not joined to a domain, so we can't sideload things by default. You have to use this developer license. To get the developer license, you can go into PowerShell and you can use the show Windows. Why is it not typing? Show, it was typing. Show Windows developer license registration. And that takes a while to start up, and that's the normal one that we get when Visual Studio asks us. If you sideload an app using the included PowerShell script, that's what it uses as well. I've already put one on here. So let's not go through that. Next up is installing a certificate. So the certificate that your app is signed with needs to be installed on your computer. In this case, we're using provisioning, which means that, sorry, and I should have covered this off earlier. Provisioning an app means that it'll be installed for every user on the machine when they log in, right? So we're not going to run this PowerShell script for each user. We're just going to automate that process away. But that requires this certificate to be installed for all users, and that's this guy over here. This package is the normal one that Visual Studio creates for you when you right-click on your app and you say create store, create app package, and yeah, create a normal default one. That's the certificate that your package is signed with, so we want to just install that. Install certificate, and we want to do it on the local machine so it's there for all of our users. And this one needs to be in the Trusted People store. Now again, in your company, you will use a proper certificate, not the one that Visual Studio generated for you, one that you get from Thought or one of those guys. Next, finish, and our certificate is installed. Okay, next one, let's create a new user. We're using the command prompt over here for creating our user. You can do it through the normal way. We're just saying that there's no password for this user. And we'll do that because we want that user to be able to log in automatically. Then next up, we're going to provision our app package. So there's this thing called DISM. It allows you to edit your Windows image. And there's PowerShell things for provisioning it. What's important on this one is the dependency package path. If you've got an Apex package that references other packages, like the Win.js library, you have to specify that in your dependency package paths. That's what the end over here is about. What's that doing? Sorry. We enter, and we'll start deploying our package over there. So, next guy. Okay, so normally we will now exit our, we will sign in as our new kiosk user, go in there, and we'll just check that the app is over there, that it's been deployed correctly, and then sign that guy back out, come back in here, and then set up our app launcher. App launcher is an actual application that runs on the computer, and so you would want it to be in the registry and the run command. We just say embedded app launcher is embedded app launcher.exe. It points to a particular exe. That application runs when our app starts up, and it reads some other stuff in the registry that tells it how to work itself. So next one, actually, in the interest of time, how much time do we have left? Are we over? Okay, 2 minutes. I'll run through these guys with you. So app launcher, we've told it to run app launcher when we start up. PowerShell, we use WMI objects. WMI is awesome. It's a great way of managing your system. We use that to get an app ID, the app user model ID. You'll see that when you go to your packaging tab on the manifest, right at the bottom. That's the ID by which your app is known to the system. So we get our ID, we get a user ID for the kiosk user. Again, we're using the WMI thing to get the SID. And then, again, with WMI, we tell app launcher to, for that user, load that app up. And the default return code action is 4. So if the app exits, do action number 4. There's a little table that says what each does. And your options there are to restart the computer, sign the user out, restart the app. There's one other one. Now, those are the important ones. Do nothing is the other one. And then next up, gestures. To lock down our gestures, that's a registry key that we have to set. You bitwise OR a whole bunch of values together. And if you get to 255, you've locked down all of the different gestures. Then auto login, one of my favorites. You can set in your registry, in the win logon key, you can say do an auto admin login, then default username should be the kiosk user, and because we've specified no password, we can just leave this one blank. Now the effect of all of this should be that, let's quickly apply that one. Okay, we're in the sign out one now. And if we go power, restart, while that's doing that, let's quickly go through some of our other slides. Okay, demo, what we went through, those are some tools that you use to configure Windows Embedded. ICE and IBW is for Windows Embedded Standard, SIM is for the unattended setup, and System Center for deploying things. MSDN lab exercises. This is everything that we did right here now, but for Windows Embedded Standard with a kiosk app. They provide the source code. They provide a good step-by-step tutorial to go through everything. Some other useful links. Okay, let's quickly switch over here. So our VM is starting up. The first time that you start up and logs in automatically with a new kiosk user, it takes a while because it needs to deploy things like the control panel. So another compulsory slide, the Windows App Game Competition. Please have a look at that. Enroll, write a game, win stuff. Evaluate the session. Sorry, it went on too long. That's the Microsoft one over there. Unfortunately, this guy is still starting up. It's a little bit slow. But yeah, I'll leave it on this one and let the next speaker come set up. Sorry for the time. Okay.